In this video lesson, we're going to review how to calculate pH, and we're going to be introduced to a new concept, pOH. To do this video lesson, you're going to want a copy of this handout, pH and pOH. So just remember from grade 10 and from grade 11 chemistry that pH really means the power of hydrogen. It's a numerical value that communicates concentrations, and when we move one number in the pH scale, the concentration of the hydrogen ion is actually changed by a multiple of 10. So if you have a pH of 3, the hydrogen ion concentration is 1.0 times 10 to the negative 3, but if you move to pH 4, it becomes 1.0 times 10 to the negative 4. Last year we learned these two pH equations. We learned that to calculate pH, we can take the negative log of the hydrogen ion concentration. And then we also learned to calculate hydrogen ion concentration, we can just go 10 to the power of negative pH. So we'll quickly do an example of that. If we want to calculate the hydrogen ion concentration, if pH equals 10.33. So to solve this, we're going to write out a formula. Hydrogen ion concentration equals 10 to the negative pH. Sub in our number, 10.33, and just punch this into your calculator, and you're going to get the hydrogen ion concentration is 4.7 times 10 to the negative 11, and our unit is in mole per liter. Now, the reason that we have only 2 digits here is because there's 2 digits right here after the decimal point. So it's the number of digits that you have after the decimal point that tells you how many significant digits you're allowed to have in your concentration. The next example we'll look at is we want to calculate the pH of a hydrochloric acid solution that has a concentration of 4.7 times 10 to the negative 11 mole per liter. So again, start by writing out your formula. Before we write out our formula, though, we should just note that because our hydrochloric acid is a strong acid, we know the hydrogen ion concentration is going to equal the same as the concentration of the solution, 4.7 times 10 to the negative 11. Okay, so we got our formula, and then we'll sub in our information, and then we'll solve. So just punch it into your calculator all in one shot. Remember to use brackets around that concentration. So remember when you put it into your calculator, you put that bracket here and that bracket here. So you punch it into calculator and you get the pH equals 10.33. So if you're paying attention, you're going to notice that our first example and our second example are just asking the opposite thing. And so it proves that our formulas are correct. The pH is used to calculate the concentration of the hydrogen ion, but we can use something called pOH to measure the concentration of the hydroxide ion, and it uses exactly the same formulas. So our pOH is going to equal negative log to the hydroxide concentration, and our hydroxide concentration is going to equal 10 to the negative pH. And then because when water ionizes, we get equal amounts of hydrogen and hydroxide concentrations. If we did the math and we did the proof, we would see that pH plus pOH of any substance is going to equal 14.00. So because there's a relationship between pH and pOH, we can use one to calculate the other, and we can also use one to calculate the concentration of the other. So we could use pH to calculate the concentration of hydroxide ions just by working through a couple steps. And that's what we're going to do on the next page. So in this first example, we're going to calculate the pH, pOH, and hydroxide concentration of a 0.042 mole per liter solution of HNO3 aqueous. So a couple things to note here. This HNO3, this is nitric acid, and we should be recognizing it as a strong acid. So that means that it's gonna 100% ionize into hydrogen ion and a nitrate ion. So it'll look like this. Also, because it's a strong acid, we know that the hydrogen ion concentration is going to equal the concentration of the HNO3. So because we have our hydrogen ion concentration, we can really easily calculate pH using pH equals negative log hydrogen ion concentration. So we write our formula, sub in our information, punch it into our calculator, making sure we use brackets, and we get a pH of 1.40. So that was our step 1, calculate pH. Step 2 is we're going to calculate pOH. And that's really easy because we know pH plus pOH is going to equal 14. So we just have to rearrange. pOH is going to equal 14 subtract pH. Sub in your number, 14 subtract 1.40, and we get a pOH of 12.60. Before we move on, I'll just write in our step here so you have instructions. Our first step was to calculate pH. You can squeeze it in if you want to. So we calculated pH, we calculated pOH, and now for our third step, we're going to calculate the last thing it's asking for, the hydroxide ion concentration, and that's easy enough because we know that the hydroxide ion concentration is going to equal 10 to the negative not pH, 10 to the negative pOH. So 10 to the negative 12.60. Punch that into your calculator and we get 2.5 times 10 to the negative 13 in our units. I'm just going to squeeze them in under here, is mole per liter. Then if you really wanted to be get great communication marks, you would write me a therefore statement to finish off this question. So there's our therefore statement. So in our next example, it says calculate pH and then a 7. So you need to scratch this out and turn it into an and. So we're looking at the pH and the pOH of a solution that's prepared by dissolving 4.3 grams of barium hydroxide in 1.5 liters. So again, we recognize that the barium hydroxide is going to be a strong base. So that means it's going to completely dissociate into its ions. So the dissociation is going to look like this. We also know that because it is making 2 hydroxides here, that the concentration of our hydroxide ion is going to equal 2 times the concentration of the barium hydroxide. Okay, so it's a 1:2 ratio. This 2 doesn't belong here. It belongs here. So we need our concentration of our barium hydroxide in order to get the concentration of our hydroxide. So our first step is going to calculate that. So we set it up like a factor label method like we've seen before. We take our mass and we're going to times it by our molar mass. So in case you forget, molar mass is here. So that would give us number of moles if we stopped at this point, and then we times it by 1 over 1.5 liters, and this is going to give us a concentration of barium hydroxide to be 1.7 times 10 to the negative 2 mole per liter. So what this means is that our concentration of our hydroxide ion, oh no, not our hydroxide ion, was that? Yes, hydroxide ion. Is going to equal 2 times this number. So 2 times 1.7 times 10 to the negative 2 mole per liter, and do your math. And we get a hydroxide concentration of 3.3 times 10 to the negative 2 mole per liter. So then I guess this is really our third step because we've calculated hydroxide concentration. But our next step is we're going to calculate pOH. So we'll write in our formula, substitute in our concentration, and we solve it for a pOH of 1.47. Then our last step is we're going to calculate. That's easy enough because we know that pH plus pOH is going to equal 14. So we just need to rearrange. pH is going to be 14, subtract pOH. 14 subtract 1.47, you get a pH of 12.53, and you could finish this off with a therefore, but I don't have the space, so I'm not going to squeeze it in. So those are some examples of how you can calculate pH and pOH and some ion concentrations using essentially 2 out of the 3 pieces of given information. So that's all for this video lesson. There'll be some practice posted for you as well, but it's pretty straightforward, so you shouldn't have any problems with it.